Okay, hello everyone. This is a physics project working session working on metamathematics. And we are homing in on our understanding of the relationship between metamathematics, physics, the Roolead, and all those good kinds of things. And we are deep in various technical issues, but we will emerge on a variety of things. So today, let me just create a, let me make a little list of things that I would like to take a look at today. I'd like to look at the correspondence with automated theorem proving. I would like to look a little bit more at the model theory stuff, probably. I'd like to look at the I guess we've been calling the UR level. And what else did we say we wanted to look at? That's probably, I'd love to do more to operationalize our theory of truth.
Sure.
Okay, but let's start off with the correspondence with automated theorem proving. Okay, so this is going to be, so I want to, I've got this version here. What was this now? This was, okay. What is this now? This was the cases of, oh, I see. This is, how does the automated theorem prover get to the things which are in the token event graph? Okay, right, I understand. So this is something we should be able to get directly. This is Nick's find proof function, finding proofs within token event graphs. This is find equational proof, which goes to this, which does this kind of backwards thing with the evolving to true. Okay, I'm gonna create another file here. Metamathematics 47. I don't know what to do when I have a project that goes across a year boundary. I guess we keep on going with Mathematics 48, but in 2022.
Yeah, I wouldn't recommend restarting the numbers.
I'm not going to.
Yeah.
Okay. All right. So now you've got install the Packlets and install this. Why is it taking so long to install that Packlet? Should I be suspicious here?
I don't know. Don't worry, there is no any malicious software inside.
It didn't take this long. I just installed it and it was instant.
Yeah, we just tested it.
Yeah.
Well, I wonder if there's something that was already running here. Let's quit the kernel. Just think how far it takes to get from the UR level to 1 + 1. You know,
oh, it's a fair distance. Yes.
Yeah, I know. Old Bertrand Russell was so proud of the fact that it took him however many pages to get there. And I don't know what was going on before, but anyway, that seems to be working okay. All right, now you say I also have to run code 01. Is that correct? Nick?
Yeah, well, depends on what we want to do. Because it's still unclear. There's not like any new functionality per se, I just moved all the code inside the Packlet.
Okay, but should I evaluate all of this?
Yeah, as before. Or just the gray cells, the saturation cells.
Okay, the thing we were coming around to is the question of, can we rotate around
Mhm.
this proof object to token event graph? We want to, okay, so our objectives here were rotate the proof object graph so that we see a direct computation. That's one thing. And then another objective is display what got transformed
Mhm.
as part of the event.
The events, especially for co-substitution.
Yes, because this is the beginning of what we need for the general multi-computation. You know, this is what we're going to need in some sense. Okay, this process here of a single chain, well, okay, oh gosh, now I'm so confused. It's kind of like the main evaluator in Wolfram language. You're just doing a chain of things. The only difference between that and this and the main evaluator is that here at every step, you're gulping down the whole expression here, if that makes sense. Whereas in the evaluator, you are going into subtrees in that expression to replace them, which is not what you're doing here, right? Here we're always saying whole expression to whole expression, this token event graph.
Or why? No. Find equational proof has steps that go inside the expression, have positions.
No, I realize that, but what's in the tokens here, you know, okay, so in our TEG for Metamathematics, the tokens are complete mathematical statements, right? As opposed to something where in the physics project, the tokens are disembodied hyperedges. Am I making sense?
Yeah.
Mm.
Like just terms.
Yeah.
Actually, that's my goal is now to just take proof graph or just the proof object and try to basically extract from it just a path from, like, your hypothesis is inequality. It has one
Mhm.
term equal to another.
Mhm.
I want to extract an actual rewrite path, how you rewrite one of the terms to another, going through all these substitutions and co-substitution.
Right, but the point is, as I understand, okay, so that's the Fliparound, because in this kind of graph, right, this graph is our backwards graph that evolves to true, right? And I think you have a new version of this now that has, so if I do find equational proof of this, okay, great. Proof object to token event graph of that. Okay, so you're evolving to the identity D equals D. Okay. By the way, a small cosmetic thing is that I really would like these events to be able to be resized. I don't know if there's a way to do that. But okay, so now the question is, can we flip this around so that we're going from the axiom to the hypothesis, right? That's what we were discussing.
That's right.
Okay, so what's the answer to that? How much did you figure out about how to do that?
I figured out, yeah, you can reverse all the substitutions that trivial. You basically can also reverse the co-substitutions.
Okay.
And I think you can just do it on the proof data set, just a little bit tweaking. And then I want to, in the end, just write a function that just takes the data set and just unrolls everything into just one path from the left term of your hypothesis to the right term by doing just rewriting on terms from using only the axioms as your initial.
Okay, but hold on. I think those are two different things. That's a non-accumulative system, right? You can do that. That's cut elimination, and that will generally make quite complicated things. I think we should be able to do the case where it is still a cumulative, right? But where it is the flip around of this, going from the axiom to the hypothesis. So is that easier to do? I mean, so what you're saying is if I take the proof graph here, well, can I make a transformation on the proof graph to do this? Or do I have to make a transformation on the data set?
Well, if you don't want to actually verify or run this graph somehow, then you can just flip around vertices and pretend that this is new substitution. I think.
Okay. So what do we do here? So what we're doing is for every one of these, you're saying, what are we doing? I mean, what specifically are we doing to this?
Well, specifically, you start from your hypothesis, right? You
No,
find the
start from
event.
the no. We start from the
axiom.
Why does it matter?
Because that's the flow that we want. The Big Bang is the axioms, and then you're generating the hypothesis. Generating the statements.
Yeah, but it's easier because the hypothesis is usually just one. You start from the hypothesis. If it goes into event, if it goes into event, you reverse it so that the hypothesis is the output of this event. Then you just whatever arrow was kind of is a result in this substitution. It now becomes an input. So you inverse two arrows for each substitution, and you do it iteratively for every event. Like for this one is like you basically inverse all the left arrows, like the left edge of this graph. You can reverse them.
Okay, so let's see how we do that. So what we're saying is this graph there is its edge list. So now tell me what to do. So you're saying,
no, for this particular, you can just take all the edges that not include your axiom, and you inverse it. It's not going to work in general, but for this one, it's pretty straightforward.
Why? Why is that good enough for this?
Well, because it seems like all the substitution lemmas here is just using the axiom as your right rule.
Okay, all right. So let's take this then here, and you're claiming every other arrow, everything that didn't involve the axiom on the left-hand side should be reversed. Right?
Yeah.
So we're saying if first of hash not equal to this creature here, then reverse hash, otherwise hash, and map that over this edge list. Okay, how do we get the styling, by the way? If I just think
options.
Which option? Oh, you mean we pick up the options of %64?
Yeah.
Okay, so we say graph of that, comma, options %64. Wow, that was cool. Wow, that was easy. Okay, let's see if this is correct. So D equals D. That's kind of a weird thing to put in there. And by the way, presumably we can recanonicalize all of these. Is that true?
Yeah. Yep.
So, and if we recanonicalize, then this thing here will actually be the initial axiom again. Right?
Yeah, it looks like.
So then this becomes a double application of the initial axiom.
Yep. then triple, and that's it.
Okay. So then what we're learning here is that this hypothesis so this should be a fragment. So this thing here should be a fragment of the accumulative token event graph, right? The thing we get out from this should be a fragment of the complete cumulative token event graph starting from A equals B dot A.
Well, sure. Yeah.
Yes?
And if you also include this D equals D or something.
Why do we need that?
Oh, it was used for substitution, right? Well, if it also can be derived, then you don't have to have it.
I'm not sure that
Look.
it's used for substitutions here.
What do you mean? It used as a target for a substitution, right?
No, but it's
You
not
use it.
anymore. Not when you flipped it around.
What do you mean? Like the top event is taking your axiom and use it as a rule to
I know, but
substitute it.
look at it. It's not doing anything. Look, this was a hack used when the thing was done for theorem proving
All right.
as the target. I think it's irrelevant. I think it's
Yes,
a trivial.
yeah.
I think it is a necessary thing when you have equalities here. I think it's part of the meta logic that D replaced with D doesn't change.
Yeah, right. So top
Yeah.
event is just irrelevant, but
Yeah.
it's not in general, right? Just sometimes.
Well, right. So in this particular case, we can say vertex delete of
Event conclusion, I think.
this one here.
Yeah.
We really should have names for these things that are more useful. Wait a minute. Event.
In the list.
Yeah, okay. Is that going to work, or is vertex delete going to try and delete two vertices there? Well, let's do this. This has a better chance.
Hmm.
I don't know why the D equals D is still set. Oh, because we didn't delete the vertex. We only deleted that vertex. And so now here, if we canonicalize, we have to canonicalize all of those things, and then those two will merge. Right?
Yeah. Just going to be two arrows. Rule applied to itself.
Yes. So let's see, how would we do that? So, okay. So is this a general procedure that we can reverse these things? What about co-substitution? Can we also reverse that?
I think, yeah, in principle. It's a little bit trickier, but yeah.
Why is it trickier? It's got two things coming in, and what we've been doing previously is we're just
because the unification happened during the co-replacement. You have to reverse that too. All the variables that have been unified during the matching.
Okay. But so are you writing code that does this?
Yeah, kind of. Just started today.
Okay. But the objective, again, is to be able to find, we've got your find proof function that finds sub things from a token event graph, right?
Right.
Okay, so this should be equivalent to that, except that the thing finding sub things from a token event graph will be the optimal proof, and what find equational proof produces might not be the optimal proof, right?
I see.
Well,
Does that
it's
make
not
sense?
guaranteed to be optimal, so.
No, I know.
If you enumerate all of them, then probably, yeah.
No, the thing you were doing before is guaranteed to be optimal because it comes from the full token event graph. It is finding a path. It's finding the shortest path in the full token event graph. So it is guaranteed
Well,
to be
it's
optimal.
not finding the shortest path by default. It just finds all paths. Maybe if you just ask to find one, maybe it's not going to be the shortest one.
Well, okay, so let's look at a case.
Probably, but not.
Okay, so find proof. Let's see the code for find proof. Where is that?
In the code.
Is in code
Yeah.
01?
Yep.
Okay, so somewhere here there's a find path, presumably.
No, there is no such thing. I'm not looking for a find path. I'm just backtracking from the hypothesis and reconstructing all the events along the way.
Why isn't it a find path problem? Because it isn't a single path, because it's this whole bushier thing. Is that right?
Yeah. It's like, take a look at the token event graph. It's like if you find a path from the hypothesis to one axiom, it's going to ignore all the other branches.
Which are used because it is a cumulative. Is that right? If it wasn't a cumulative, it wouldn't use other branches. There will be a single path.
It's like it's hard to call it a path because it's like each event has two inputs, one output. It's not a path.
I know. But in a non-accumulative setting, right, the input is always the original axiom.
By definition. Yes.
Yeah.
Right. So
right.
In that case, this becomes something, okay. The non-accumulative case. Is that right? The non-accumulative. Yes, I think that is right. The non-accumulative token event graph is just like the path-based derivation system, except that events can be fed by different axioms if there are multiple axioms. Right?
Yeah. You get this kind of canopy of axioms above your path.
Yes. Right, exactly. Feeding different pieces of it. Now, yeah, so that's exactly what's going on here. I mean, you could say to go from a statement to another statement to another statement, just applying the axioms, you'll just get a single path. I think that's what I've described in I don't know what the difference is between. Do you know what copy draft 04 copy is? Is that something you made, Nick?
No, copy is mine. Yeah.
Yeah.
Copy is mine.
So we can make edits in it without affecting the original.
Right. Okay. So this rules applied to rules. Right. This is the pure network. Okay. Now we're talking about a cumulative evolution where we have this is the analog of the cut elimination business. Okay. So I believe that cut elimination, if I'm not mistaken, is this process of deaccumulatifying it. Okay, do you know what I'm saying? Or have you heard of this cut elimination business?
Heard of it.
Oh, I heard of it, not understood it yet.
We could just add it to the dictionary, though, right?
Yes.
Translating between. Yeah.
The lemma A used to prove this theorem can be inlined. This is so obscure. My gosh, this is made obscure. Oh, sigh.
Well, if it's just about inlining proofs inside proof, then it's kind of clear.
That it's the same thing.
Yeah.
Yeah.
Then I get it.
Right. Okay. All right. So I think what the conclusion here is that we've got some work to do, but that fundamentally we've got a way of finding from the Big Bang, so to speak, how certain mathematical hypotheses arise. Am I making sense? Because that's what the find equational proof is a way of determining that. So now what find equational proof is going to do is going to find a path to get to a hypothesis, right? Finds a path to get to a given statement from the Big Bang. Okay, so one question is, and its strategy for finding that path can be thought of as something where we are, I mean, its strategy has to do with, well, I don't know whether it's making forward and backward entailment cones. It's not really. Is that its strategy, or is that not its strategy? Do you understand what I'm saying? I mean, so we can clearly make a forward entailment cone from the axioms and a backward entailment cone from the statement. Okay.
Yeah.
Is that what it's doing as well? And then it has, but with a certain pruning, or is it ordering of which pieces of which paths to look at first? Am I making sense?
Nick, would you say that this is what FEP is doing?
Well, yeah, well, it calls old Meister, and old Meister is a, well, I thought it's some kind of refutational theorem prover. So I would guess it should have used the proof by contradiction, but it's not, so it's kind of confusing.
Well, it's using this thing called unfailing completion, and I made a decent summary of that, as I recall. Let's look at what I had to say about how it works. Let me see. If we're lucky, I have a decent description of it in here. Oh, that's a nice picture, by the way. That shows the relative.
Size.
Yeah, that's nice.
And we should probably try to. That's not useful. My God. Oh my gosh. Maybe somebody can make a note of this. This is a
Yeah, I'll make a note of
click to
it.
copy that doesn't work.
Yeah, I'll make a note of
Like,
it.
how many times do we have to go over this? Okay, so I'd say here.
Actually, like in my dictionary, I have Knut Bendix completion entry.
Okay. So do you explain? Wait a minute. Where is that dictionary?
It's in the working material.
Working materials. That's right.
What's it called?
Is it called ATP?
ATP 02 dictionary. It has all these inferences that are required with a little bit
This
explanation.
This definition of Knuth Bendix, it will require some explanation, though, Nick. I think.
So until I implement it, I'm not gonna claim that I
God,
understand
this
it.
is- I don't understand this at all.
So this is like a derivation when you call a token when graph, for example, and do some substitution lemmas, you get a bunch of them. Here it's just more a clever project, clever strategy. You also perform some kind of like deletion and simplification on top of that. So you don't like consider all the possible combinations of your rules. You also like
Oh, I know. This is
Yeah.
the thing we've discussed before about the ordering of which rules to try combining.
right.
Right. So, e.g., Knuth Bendix only with a certain ordering only combines certain statements, only tries combining certain statements, if I understand correctly. And one thing I think is interesting is I think there's some correspondence between this and the whole model theory story. I suspect, because that's another place where you're weighting statements in some way. Okay, but in any case.
But does ordering matter for model theory, for instance?
Weighting matters. I mean, Okay, so in any case, we've got a way to get from a given statement to a given statement from the Big Bang. And in general, and I don't know whether it's possible, I have no idea whether find equational proof has any hope of being able to generate multiple proofs. But, and also, and I think, Nick, you were trying to do this, if we can make something which does some approximation to find equational proof by doing the forward and backward entailment cones, and some kind of pruning of what things you look at there, because I think the thing that can happen is there can be a path, but the procedure of the automated theorem prover may never find it. Am I making sense?
Yes.
Yeah, well, that's the goal. Eventually I wanna do implement some simple strategies, like refutational theorem proving with Knut Bendix, unfailing
Demodulation
strategy.
maybe.
Yeah, maybe even model theory. So waiting.
How would model
Because
theory? What do you mean by model theory there?
Well, because I've seen that some theorem provers use models as a strategy to find proofs. I'm not sure how, but I
Well,
guess
I mean,
it's
you can find out using your find finite models thing. You can find what could possibly be true.
Yeah, and you can use it like to prune your rules, I guess, somehow.
That's interesting. Okay, we'll make a note of that. Models.
It's like what?
I'm thinking about that for a second. But I mean, the main point here is that I'm getting the architecture here. The architecture is from certain axioms, you can make proofs here by doing this sort of forward entailment kind of process. We have thought that the alternative is this kind of patching things together approach that is our more spatial approach, in which we are essentially cooking a whole collection. In this, we're driving forward to get to a single hypothesis, a single statement, right?
Yes.
In the other approach, what we're doing is we're saying there's a whole bunch of statements and we're going to fit them together.
What, into a fabric?
Yes.
Yeah.
Yes, that's what we're saying. So that's the alternative approach to sort of mathematics, is instead of driving, okay, so this is sort of different approaches to math. One is drive forwards through through entailments to a particular statement. And the other is try to build a fabric of many statements that fit together. And fitting together in our context is, as we've seen, is we've got these pieces of token event graphs.
Yes.
And we're saying that, I think this is this question of what, okay, what we had done previously has a little bit of a problem. And I think maybe we can clean that up using this Fliparound thing that we've done right here.
So what's the problem?
Okay, the problem is, let's see, in our timeless formulation here, what we're saying is, down here.
Oh no, you're not going to rain on the festival, are you?
We are co-deriving things here.
Yeah.
Okay?
Yeah.
But okay, this is directly analogous to what happens in the derivation of space in physics. Okay, so in physics, we have a causal graph, which is a directed graph in time.
Yeah.
Okay. And then from that, we make slices that correspond to plausible pieces of space. And which are two-way things. And I think the same is true here, that basically what we're doing is we're taking a piece of the multi-way graph, and we're basically assembling a slice on which you can essentially go two ways. So in other words, okay, so the choice is you drill deeply to get to, how do you get to a given complicated statement?
Right.
Right?
Yeah.
And so one possibility is you have already found it somewhere with all these different initial conditions, and you can find that you can hop from one thing to another to get to it.
But you have to already have found it, you're saying.
Well, I'm saying that the approach is you take a bunch of hypotheses and you start producing entailment cones from them.
That's right.
And some of those entailment cones, and when those entailment cones overlap,
Then you
that
get a fabric.
yeah, but you get a fabric. But the problem is it's only a one-way thing, right? The entailment
Right.
cones are coming down,
Yeah. I
and
understand.
they're overlapping. But the fact that you can travel through the entailment fabric is not obvious,
Right.
right?
Right.
It's the same thing as you have in space, where you have a causal graph, and you take a slice of the causal graph, and because the light cones are both forward and backward light cones, you can travel in the effective space that you get from making a slice. You're not really traveling in space. You're really going in little, fragments of the causal graph. But you can have the fiction of saying that there's a single slice of space, a single instantaneous slice of space. Does that make sense?
What if you include the backward and the forward entailment cones in the fabric?
Well, that's what you have to do.
Yeah.
That's what you have to do.
Right.
But I mean, those are symmetrical. So I think all
Exactly.
it does is to make those arrows be two-way. I
That's
think
the whole point. That's why I bring it up. Right.
Yes. So that's what that does, and so that means that you can walk through the entailment fabric. And the issue is, if you hit a white hole in the entailment fabric, then it's inconsistent.
Oh yeah. Yes. You don't
And
want
so
that.
the goal is to dodge. It
Mhm.
reminds one of these sort of science fiction movies or something, is to dodge the white holes. That is what you're trying to do, is you're trying to build mathematics. In the second one, it's like you create a two-way graph by including both forward and backward entailment cones. And then, the goal of math is to find hypotheses, find statements that fit together and don't produce white holes.
Right. I mean, it's basically the art of following entailments, but within, like, protected by a firewall against, rule viruses and white holes. And this is why we have
so
truth.
one question is, so truth in this case, this is telling one what it means. This is sort of a constructive version of truth. But one thing that surprises me is that there's one thing which is a true rulal virus that just blows up completely.
Yeah.
It just surprises me that there aren't masquerading white holes, so to speak. In other words, that undecidability doesn't cause one to say, is it a white hole? I don't know if it's a white hole. That's essentially Gödel's second incompleteness theorem, that you sort of can't tell if it's a white hole or not.
That's interesting.
You can't tell that, something might be an in-your-face infinite spewing out of statements, or it might be something that is, it might infinitely spew statements.
Yes.
Obviously so. There's quotes, obvious white holes versus unobvious ones, where the thing might, in fact, okay, what does it mean to have an inconsistency? What it means to have an inconsistency, and our claim is, okay, is it the case that an inconsistency means you can reach all statements? Inconsistency / falsity.
Well,
the
yes.
ability to reach
Yeah.
all statements.
This is like the principle of explosiveness, right? That you can conclude any statement from a contradiction, basically.
Right. Okay, so
Oh, it's principle
I
of
think
explosion, actually, not explosiveness.
okay. So, this relates, I think, to sort of the philosophical logic question of, this constructiveness. It's basically saying, if you state a statement, does it mean it's true?
Yeah, well, I want to push back on this notion that it's constructive a little bit in the sense that, okay, so we're doing metamathematics in the Ruliad, right? So all rules are technically there. So instead of asking whether or not you can construct a statement, now from the multi-computational fourth paradigm, observer theoretic point of view, it's not so much can you construct this statement because all the rules are there. What we really want to know is, which statements are useful for the mathematical observer, and why does the mathematical observer sample from the Ruliad in a somewhat selective way? I think it's different from constructive mathematics now in this new paradigm.
Yeah, no, I agree with you. I mean, let me just make a slightly different thing here. I'm just going to move this here. Okay, so constructive math versus, we need a term for this. This is kind of observer.
Well, one question I've had is, ever since the multi-computation post was released, there's this notion of fourth paradigm science, but it hasn't really been included in titles, really. How do you want to approach that? Because in some ways, I view this as metamathematics that's informed by questions that naturally arise when you accept the fourth paradigm, or when
right. So you're saying this is kind of fourth paradigm mathematical mathematics.
Yeah, or multi-computational metamathematics or something like that. Yeah. Because then you get the notion of the Ruliad, the observer, all of this kind of comes in neatly in the paradigm that we've already started to build.
Okay, but let's understand how it relates to constructive mathematics. Okay, so in philosophical logic, for example, there's always the question of statement X versus statement X is true. It is raining versus it is true that it is raining.
Or even it is raining without the quotation marks, right? In the disquotational theory of truth. Remember this? Where it's, the statement, it is raining, in, the quotation, it's true if and only if it is raining. I don't know if you remember this headache-inducing.
Yeah. Okay. But either way, now what we've got is, the Ruliad. All statements are in there.
That's right.
Right. So now the question is, but the issue is, which statements can a coherent observer kind of patch together?
Right. I mean, in some sense, the Rulliad is a constructivist dream, but it's also a constructivist nightmare because it
Yes.
means you can't just say something's false because you can't construct it because it's there, but you've excluded it as an observer, so you have to be able to account for it. It's a different approach.
Right. So it's a very interesting slicing of the constructivist approach versus other approaches, in my view.
Yeah.
Again, not seen coming.
Indeed.
Okay, so, and one definite badness is if what's patched contains a white hole, then you're toast.
Yeah.
So in other words, as soon as you include that idea, that can't work. Now, what is the role of completeness here? So in this timeless view, what is, okay, so incompleteness, what is it? What it is there are statements out there that you can't reach. There are, okay, so it's basically all it's saying is there are statements out there that you cannot reach. That's complete. Well,
so hold on. So you can't reach them from where? Where are you?
The fabric you're building up. You can't reach from the fabric you're building. Okay, and so the axiomatic approach is build your fabric from a small number of build your fabric by moving outward from a small number of axioms.
Yeah.
Which isn't necessarily what you do. You could look for consistency. So now completeness is let's see, inconsistency. Inconsistency is you're building outwards from the axioms and you hit a white hole. I believe then what's happened is okay, so what is completeness? Okay, completeness is
so you can reach the statements.
And you never reach a white hole. You can reach all statements, not all statements altogether. You can reach a definite set of statements. Let's see, your procedure, your laws of inference. This is a clash of cultures, LOI.
Yeah, what is it? Letter of intent?
Yeah.
Wait, now I've forgotten what we're using it for.
Laws of inference.
Law of inference. Okay. Yeah, okay.
Which have a certain similarity to letters of intent. It's what follows. Anyway, your laws of inference can reach a definite set of statements let's see, whatever can reach but never hit a white hole. So what is negation? If we're really right that we should think about this as a white hole, negation would be some kind of time inversion of that.
Well, one question I had, and I think Nick might be able to help with this, is are we distinguishing between negation and falsity? I mean, I understand falsity, right? The framework between truth, falsity, and how the choices that the observer makes. But on the other hand, I've even seen Nick make, say, token event graphs, where he's basically treating the token event graphs as like a conjunctive normal form statement. And those tokens have, exclamation marks in them. They have like negations in them. So are we going to distinguish between those two, between the overall falsity and, statement by statement, token by token negation, or not?
I'm not sure, but one thing that I would like to see in these festivals is a white hole.
Oh, well, let's just take let's take the virus and put it in there. Like A goes to BC if we're doing it with strings.
Okay, so you're saying what's happening here? What the heck is this? What is this? This one is so this is these statements. Okay, so let's take this here. And okay, so there's one of these. So now what do you say is a white hole? What will be a white hole?
A two-way rule BC.
Why is that a white hole?
Well, at least when we did it not with strings.
No, the strings is different because it doesn't have pattern variables.
Right.
Okay, so I claim that a good white hole here would be nothing goes to A. Oh, for goodness sake. We can't do that.
What about
Actually,
blank?
A goes to A. A will be a decent. What's
Nick?
going on here? It's not a valid association. Oh, shoot. I just did the trivial thing. Sorry. This is what I want to do. Null string goes to A.
All right. Okay, so this purple.
So far, was that the purple piece?
Yeah, and in the corner here with the blank.
Was the purple, instead of people, it's purple string eater. Nick probably does not understand that particular ridiculous cultural reference, and for good reason. I don't even necessarily understand. I don't even know what that came from, but anyway, never mind. Okay, but what this would do is this should generate, but it won't be obvious from here that this generates an infinite. Is it the case? Okay, if we just do A goes to blank goes to A.
Okay.
My gosh, what a mess.
Wow, what did you expect? It looks pretty virulent.
Okay, if we say vertex list of this, so the claim is going to be here that if I say string length onto this, map string length onto this at level 2, and then I say /dot two-way rule goes to list, and then I say list plot. Yes, we're going to get all the cases. We're going to get everything.
Yep.
Fairly obviously, we're going to get everything. On the other hand, even with this rule, okay, why does an observer get toasted if they include this rule in the rules that they say are going on? Because it does take a few steps to get toasted. You don't get to everything immediately.
I kind of find it difficult to interpret the string case. I mean, if it was it's easier when it's variables for me to understand. So
what is the analogous case then for variables?
Well, if you have like X two-way rule Y, Z or something, it's more clear to me how you're going to get absurd statements in that entailment cone. Which of these are absurd? Which of these are shredding?
I don't know. I mean,
in a string case.
Yeah, but I mean, you can think of the string case as being like word equations in a group.
Okay.
And this is saying that all word equations are true. Right? For a group, okay, as opposed to the free group, which says that no word equations are true.
Okay.
This is the opposite limit.
Yeah.
I don't even know what that means, but when all word equations are true, what does that mean for a group?
I don't know.
Okay. But so what we're saying here is
it's just a trivial group with
What's
identity. That? It's just a trivial group with identity.
Oh yeah, that's right.
Only.
Okay. So again, what we're doing here is we're saying, given an axiom, it could be the case that the things we can get to by kind of this lily pad hopping process will never have something that just starts generating all expressions, that there's a limited set that we can get to by kind of hopping around. It's a very weird thing. I have not wrapped my brain around this claim yet.
Which one?
The fact that falsity is the statement that everything is true. That's what basically.
Wait.
Falsity is equivalent to the statement. Okay, so what it's saying is, there's sort of a definition of falsity, which is related to this explosion idea. Yeah. Definition of falsity. Something is false if assuming it makes everything true.
That's right.
That's the basic definition of falsity.
That's right.
Let me just wrap my brain around that for a second. So if I say, it's just not what we intuitively, I mean, if I say the moon is painted on the sky, a statement which we believe to be false.
Well, it's harder when you, an easier thing is, that like 3 equals 4 is false. Because imagine if 3 equaled 4, then,
Okay. assume 1 equals 2.
Sure.
So what? How do we go from 1 equals 2 to everything being true?
It's not like it's a novelty generation. It's not
It's what?
that it gives you. It's not that it gives you novelty generation. It's that if you given some proposition on top of that, you can use this statement to prove it, no matter what you are given.
Somehow this reminds me of politics or something. If you start with something that's just nonsense.
Yes, then you get what? George Orwell.
I guess.
Well, isn't that some motif in Orwell, right? That people are taught some ridiculous, untrue arithmetic statement. I think I remember that.
Oh, that's interesting. But okay, so walk me through the process. You start from something that like 1 equals 2, and then how do you use that? If 1 equals 2, I see. If 1 equals 2, then any number, okay, with the Peano axioms, I think we could say then any number is equal to any other number.
Yeah, because 1 plus 1 equals 1, and you can go from there, right?
Right.
The whole thing's gonna, I mean, you can kind of, it's like a shredding simulation. You trying to think about what happens when 1 plus 1 equals, or when 1 equals 2. You can kind of mentally compute the entailment cone from there. And all of a sudden you can see, everything starts to collapse.
Well, but you see, the thing that is so strange is this kind of wraparound of when you assume something which is false, it means everything is true. That's what I'm having just a bit of a hard time wrapping my brain around.
But that's not quite it, right? It's if you assume something's false, what it means is you exclude it from, say, your fabric, knowing that inclusion of it into the fabric will result in entailments that are explosive.
Yeah,
but are not tractable mathematically.
No, but hold on a second. But being explosive is going to be a statement that it means everything is true. And the whole point is the statement that everything is true. The whole point is this kind of strange wraparound between everything is true is equivalent to everything is false. Like that's what's happening is if, quotes, everything is true, that's equivalent to that's what we're claiming, basically. If everything is true.
Well, it's that if everything, hold on. So if you have some sort of fabric, for instance, as an observer, you're assuming that your fabric is true. This is the first thing. It's in your reference frame. Okay, yep. So when everything is true, what that actually means is that your entailment cone or your entailment fabric, includes all possible statements. Right? And so what you do when you assign falsity is you assign falsity to the germ of that cone that would include all statements.
I know. But the thing I'm still trying to wrap my brain around is the idea that you detect falsity by this principle of explosion, by the idea that if you assume that false thing to be true, then everything becomes true.
Yeah.
Okay, but I that's not a self-evident idea.
Oh.
I don't think that's a self-evident idea. I don't think that when people first started talking about things that are false, basically,
Well, sure,
it sort of reminds me.
they're not going to talk about it that way, but the whole point is we're situating them as observers, in the
I know.
Roolead, whereas they're not doing that before. So the whole point is to start thinking about falsity in terms of this firewall that you set up so that your mathematics that you do, is mathematically
Okay,
true.
but hold on. The basic claim is once you claim something to be true, that is in fact false, like 1 equals 2, or
Yeah.
that once you make a claim like 1 equals 2, that virally infects everything you're doing.
Yeah. And there's no herd immunity to a Roolead virus, by the way.
There's no adaptive immune system for mathematics, presumably.
Well, but the only thing is, not to extend this metaphor unduly, but the whole point is that falsity is kind of like your immune system. That's the point. You can protect your fabric, so to speak, by exclusion of these germs, where no pun intended, where the entailment cone of the germs would be explosive.
Yes, but I'm still not completely happy with the idea that, in traditional logic, truth and falsity are on more or less the same footing. Okay, what's very bizarre here, what's interesting about this, okay, a little bit philosophically here, in our physics project, one of the bigger cognitive jumps is space and time are not the same kind of thing.
Okay.
What's being claimed here is that truth and falsity are not the same kind of thing, which is quite interesting if true, right? In other words, truth is, can you get there in your fabric?
Yes.
Right?
Yes.
And falsity is, if you get there, it will explode. You will be able to get everywhere. Okay, so in other words, that's basically making the claim that truth and falsity are completely different kinds of concepts. Which is, by the way, not unsupported by the way that material implication works in logic.
I suppose what it says is, if you try to, though you can't, but if you try to adopt a reference frame that encompassed the whole Roolead, one, you wouldn't be able to do mathematics, and it would include things that you probably should say are false. So in some sense, truth is like some little nice mathematically tractable pocket within the Roolead. That's the point.
Right. Yeah, so truth becomes a region of statements that have certain kinds of consistency, certain coherence, consistency.
Yeah.
Put another way, and this is unfortunately, it suggests, okay, so in the world of relativism and different truths type thing, what this is saying is, well, is it saying that or is it not saying that?
Saying what?
Well, okay, there might be two different fabrics. Yes, it does say that. There might be two different viable entailment fabrics which both avoid white holes. but which contain different stuff.
Sure.
But that's a statement of incompleteness. This is a consequence of incompleteness, because if it wasn't for incompleteness, then you could always get to any place that was viable that didn't have,
I see.
right? You'd always be able to get there.
So does that mean that with incompleteness, truth actually isn't a region, but it's like an archipelago or something? It's like actually like a number of different pockets. You can't necessarily actually reach one from the other.
Right, because of incompleteness.
Oh my goodness. What a world.
Well, so what that would mean is if, right, so how does that play out? That, I mean, how does that relate to the statement of incompleteness in terms of finiteness of, that there are infinite proofs? That's like saying, I think it's like saying you can't get from one piece of fabric to the other. You can't guarantee to do that with a finite proof. And you can't know. You put out, there are search parties that go out from one island in the archipelago, and they don't know whether the ocean sea is finite or not, so to speak.
Something like that.
Right. I mean, the search party goes out, and it's like, is there going to be some other island, or are we just going to all, die of scurvy?
Get scurvy. Yeah. Yes. Yes.
Okay, I actually like that analogy of I wonder how many times I've written the word archipelago, which I don't know how to spell. How do you spell archipelago? That's definitely not it.
It's with an A instead of an E.
Archipelago. Okay, I'm going to determine one thing, which is the number of times over the last 30 years
Oh, okay.
that I've written the word archipelago. Oh my gosh, it's a lot more than I thought.
But was it metaphorical, or were you actually looking at islands?
Oh, you know what? There's a lot of stuff around the time of the creation of Wolfram Alpha. It's
Yeah.
It's actual archipelagos.
Yeah.
Archipelago of islands of truth.
Yeah.
Not clear, non-finiteness of proofs. Yeah, you don't know. You've been looking for another island, and you've been looking for it for a few months, and you have no idea whether it's there or not. Okay. So if there was completeness, there would be a single fabric that avoids. I mean, I just want to come back to this point. I don't know if it's a pity we don't have some other folk here who might have interesting views on this. Maybe somebody could see if they could find Xerxes. He might have an interesting view, and or Hatem.
I'll message them.
Okay. Okay, so the question here is, I mean, this is a very interesting claim. It's basically the claim that truth and falsity are not the same kind of thing, just as space and time are not the same kind of thing. I wonder if I really, I mean, it seems somewhat plausible. And that then gives one, again, I don't know enough about the philosophy of constructivism to know if that kind of gives one a bridge to constructivism. Okay, what is the law of excluded middle in this? Okay, so here, Because that requires negation and all kinds of other things. The law of excluded middle might be taken to say, okay, what is the negation operation? That's another question. What is the in this interpretation of truth versus falsity, what is negation?
That was the question I raised before, right? Which is, on the one hand, I don't know, can we treat falsity as semantic negation, but still keep like syntactic negation, like in token event graphs, for instance? This is the kind of question that I've had before.
I'm sure the answer to that is yes, but I'm Okay, let's ask another question here. As we go down below the axiomatic level to the Ur level,
Yes.
what happens to all of this? I don't think it changes very much, actually. I think the only change is that we can't identify. I mean, this whole issue of so there is a notion of truth at the Ur level. The problem is that we don't know what we're talking about at that level.
Well, I mean, in my interpretation, the Ur level is pretty much pre-observer. So you'll have.
Yeah.
What, do you disagree with that?
I disagree with that. I think it's perfectly reasonable to the Ur level, at this level of making islands and things, that can be happening at the Ur level. The issue is the observer only sees certain coarse-grained aspects. I mean, there can be island formation happening just fine.
Yeah. Yeah, but that's what I mean when I say pre-observer, in the sense that the observer can't observe, the entirety of the activity at the machine level, because there's coarse graining going on. So it's kind of inaccessible.
Agree. So there's many grains of sand, so to speak, not to stretch more analogies even further. I mean, in the archipelago, at the Ur level, you're seeing every grain of sand that makes up all the islands.
Yes.
And that could be pretty confusing. As you zoom out and you coarse grain, not to really horribly distort this whole analogy.
Well, my question was, at the machine level, like, let's say you were looking under a microscope or something, could you tell if you were looking at a sample from an island or from, say, the water? This is
not a chance. Not a chance.
Well, that's the point then. So at the machine level, you have what could become ultimately.
I see.
It could lead to, see, the way that I view it is, you'll have something at the machine level, say a fixed point from multi-way combinator. That could be an axiom. It could be mappable to an axiom. You have a model in which that becomes an axiom. And that could have an entailment cone that's perfectly fine. Or it could have a virulent entailment cone.
Okay.
But you don't, but until it's included into something that the observer will work with, a reference frame, you really don't know.
Right. You can't really tell what's going on, as in the analogy is that clump of molecules actually a tornado? And you just have no idea.
Yeah, right.
Part of a tornado. Now, what about the high level? What about the fluid dynamics level? So at that level, what can you tell about? You might have results that allow you. So what is the, okay, so we have this whole sort of derivation, laws of inference type mechanism at the axiomatic level. how do you do mathematics at the fluid dynamics level? That's what actual mathematicians typically do. But how do you formalize that mathematics?
Well, that's all, you know, that's all archipelagic, right? That's all on land. That's the first thing. And for the most part, you don't even necessarily go near the shore, so to speak.
I'm not sure that's right. I'm not sure that's right. I think it's simply that you are looking at it. I mean, I think unfortunately we've got multiple archipelagos going on here, but I see you're saying at the high level math level, you imagine that you are always on an island, though you don't necessarily know, though you neither know nor care which island.
I mean, but you still, of course, assign falsity, right? But you don't really consider the entailment cones of the false statements necessarily. I mean, you're still maintaining the island, right? By not including false statements into your math. So you're still kind of aware that there's the truth falsity distinction, but you're not spending a great deal of time thinking about like doing counterfactual math. You're not sailing the waters and seeing what would happen if you considered the entailments of these false.
Right, but the main thing is that the main claim is that metamathematical space is uniform enough that whatever island you're on, you can still be exploring. In other words, whatever detailed axiomatic foundation you have, you can still be exploring the same math.
Now, what work have we done on our kind of conjecture about the homogeneity of metamathematical space? What can we say about it? Have we done anything with it? How could we kind of demonstrate?
Well, I mean, it's basically functors between different, categories. I mean, that's the meta claim is that all these different areas of mathematics are equivalent. So look, this is about, equivalences between areas of math, and there is a, computation universality implies a certain equivalence.
Universality.
Right, but that's the thing that allows one equivalence, but it grinds things up. In other words, it's equivalent as in, e.g., everything is made of material atoms. Okay, but it's still the case that, that's the universality of matter, so to speak.
Nice. Yeah. Okay.
But it's not particularly useful to say. I mean, like the alchemists had that issue. But alchemical transformations are not easy. So that's really the question: is math fluid enough that that observer level transformations can be made between different areas, non-observer shredding transformations? Because by the time you're dealing with the, universality of matter and everything is made of atoms type thing, it is in a very literal sense to go from a piece of cheese to a what's a good example? What's a good example here? Yeah, I mean, even to go from, the oil that you pump out of a gas pump to a random plastic toy, the atoms are the same, but you can't get from that. I mean, the question is, can you get from one area of math to another without molecular scale manufacturing, basically? And because you can get, it is correct that matter is universal in that sense. And you can get from the, from the gasoline to the plastic toy, they have the same atoms in them.
Yes.
But to get from one to the other, sort of, it's not obvious that there's an observer level way to get from one to the other that doesn't require individually rearranging atoms.
This is like the difference between physical and chemical transformations, basically.
Maybe. I mean, yes, yeah, I suppose that's true. I mean, chemistry does get down to the level of individual molecules, whereas physics tends to move things around with thermodynamics and so on, where you're just. But in any case, the fact is, the question is there a high-level equivalence between different areas of math? We know there's a low-level equivalence because of computational universality.
Well, but isn't that kind of what much of contemporary pure math pursues? Is establishing higher level connections? It's kind of
yes, right. But the fact that those exist, in other words, the existence of low-level connections is unsurprising. The existence of high-level connections appears to be a consequence of this emergence of, of what the mathematical observer is like. That is, it could be the case that a different mathematical observer would think it was really interesting what happened down at the level without any kind of axiomatic structure being made, et cetera, et cetera, et cetera, or even at the axiomatic level, it's too low level, and these transformations between different areas won't be, it won't be obvious that you can make a transformation from one area to the other. There's a question, actually, there's several comments on our live stream here. Blue says, I'm not sure how extensively mathematical reasoning based on false premises has been studied. It seems to me that if you assume things about this process that are not clear, the 1 plus 1 equals 2 example, somewhat easy to understand, but is it really representative of other cases? Well, the claim is imagine we have one of our networks, even with strings. See the thing, okay, the intuition that I would have is that introducing a false statement. Okay, so a bit of intuition maybe. Introducing a false statement is like introducing a some kind of non-commensurate fraction. So when you do arithmetic, as soon as you have, once you have square root of 2, for example, if you've only got rational numbers, you can only build okay, is this true? Gosh, now I'm confused. Okay, so given rational numbers and arithmetic, you can build all rational numbers. But if you introduce, no, that isn't true. But if you introduce like square root of 2, you can build a certain set of real numbers, but not all of them. That's interesting. Okay, actually, here's the basic point. Okay, here's the basic point. Key question is there only one kind of falsity? Are all false statements? Or could you classify something as being a type 1 falsity and a type 2 falsity? In other words, are all white holes, just like black holes tend to be the same, are all white holes in the sense the same?
Well, I could take a provocative example, which is suppose that we end up finding something like a entirely or somewhat paramathematical system in this whole metamathematical framework. Well, what if falsity for that paramathematical system is different from our kind of falsity? Not sure.
Well, in particular, but look, you're spewing out statements in this white hole, but you might only spew out green statements or red statements or whatever, where green and red are defined in some way, perhaps even some syntactic way. Is falsity about generating too many statements, or is it about generating all statements?
Well, here's the thing, is that as you mentioned before, it could be the case that you have, say, a statement in your fabric that with time, you'll come to find that it's, you should have treated it as false, that it has some, virulent property, but it's not evident in the beginning. Yeah. Yes. And it could even be helpful in the beginning. And
you seem to be getting a long way. You seem to be proving all kinds of exciting things.
Yes.
And unfortunately, the thing blows up in your face.
Yes, very fairy tale like. It's too good to be true, but it turns out you weren't prudent enough. But the question is, this kind of behavior, the kind of the latency period or something for what should be a false statement in an entailment fabric, that might depend very much on the kind of fabric you have.
Including what turns out to be a false statement at the beginning, it lets you prove all sorts of useful things.
Oh yeah.
But it turns out, I like that analogy, it turns out to be, quotes, too good to be true.
Yes.
And then in the end, it overwhelms things. But the question here, what's the cardinality of false statements? What's the cardinality of statements? Statements are all possible trees, right?
Yes.
And am I being confused? What's the cardinality of all possible trees?
Shouldn't it be 2 to the L if not? Or for binary, that would be binary.
What is the cardinality of falsity, so to speak? How many statements does it reach? I mean, the interesting question would be, it would be very amusing if it turned out that falsity had the power of the continuum and truth does not.
Now we're getting somewhere. That's interesting. That is interesting.
Okay, the number of trees, I think that's right, that the number of the number of binary trees is the same. Wait a minute. The number of branches in an infinite binary tree is the number of digit sequences, isn't it? Which is the continuum.
Should be 2 to the L if not.
Right, but the number of binary trees themselves.
Oh gosh.
I'm not sure it's the same thing. You could imagine encoding binary trees. Finite binary trees can be encoded by integers, I think. I think that's what these tupling functions do.
Nick, do you have any intuition on that?
No, not really. But it seems like paucity is it's arbitrary. It's kind of observer dependent.
What
Like
is?
when
Sorry.
paucity, it's like if you have like all the possible statements, it's the choice of an observer what statements you want to be true. You just the only condition is that you make this dichotomy of all the statements into true and false, so that false is of the same cardinality maybe as all of them, and true
Yeah,
is
but
just more.
this is not what we're claiming here, right? That will be one possibility, that you simply paint the world of statements with black and white, so to speak.
Well, that's where that's where law of excluded middle comes in, right?
Maybe you can paint it with more colors. Then you use this free valid logic or something like that.
Yeah. Okay, that's a good question. How does how does three-valued logic work? How does truth versus falsity work in multi-valued logic?
Actually, I just wanted to make one quick point on this law of excluded middle. If we're considering the possibility that fabrics have what really are false statements, but it's not evident in the middle, or it's not evident at some stage, that's not exactly law of excluded middle. It's not really a law of excluded middle kind of scenario, because it's.
Well, the law of excluded middle just tells you in one propositional step you can determine that P or not P is true. But this is saying, it's saying that the law of excluded middle is undecidable. That is, it can take you arbitrarily long to determine whether this is true.
Yeah, maybe make a note of that on the law of excluded middle. Okay, anyway, three-valued logic.
Okay, how does three-valued logic relate? I mean, nobody does mathematics talking about three-valued logic. Nobody's ever talking about, I mean, you can have an everyday interpretation, true, false, and maybe type thing, but you can also just have as a formal matter. It's interesting. I mean, the existence of three-valued logic does support the idea that truth and falsity might not be the same kind of thing.
Nick, are you familiar with three-valued logic, or are you just kind of bringing it to our attention?
Just bring.
I mean, I even discussed it in NKS. It's like so many other things.
Like ultimately, it's like seems like logic in general is just a way to orient and direct ourselves in the Boolean, right? It's like if there is want any logic and all the statements, we just have no choice where to go. So like the simplest way to just somehow choose how we move is just to have logic, and the simplest one of logic is a binary one.
That's an interesting claim. I mean, it claims it's suggesting some kind of model theoretic version. It's a model theoretic like claim about what logic means and which valued logic you're dealing with.
Yeah. Should we do some model theory, by the way?
Well,
it was on the agenda.
Yeah, we're going to run out of time as well. I just wanted to look at some other questions on this live stream. We had one from Timecake about hyperruliads. All right, let's take a look at this. This may be not in a poor ruliad dweller like myself. This may be too difficult. Okay.
I basically only think about hyperruliads during these live streams when people ask questions about it.
Yes, I mean, hyperrooliads are still far away. If
Yeah.
there's an event horizon between the hyperemulation of the rooliad and the rest of the hyperrooliad, then this would make hyperrooliads non-monadic. I don't know what that means. So it's being in the rooliad is a contingent fact, but could the monadicity of the rooliad be a criterion by which it could be differentiated from the zoo of hyperrooliads? In other words, do you know? Okay, so that's one question is, okay, that's a good question.
That's
Okay,
pretty cool. Yeah.
so okay, so the issue is this. Actually, that's another point that I hadn't really thought about. Okay. Isn't it odd that or it might be odd that we are at the Turing level and not the sub or super Turing level? I find that less worrisome, but maybe it's only because of my point of view, to why aren't we in this branch of some hyperrooliad that has the, Aleph, whatever it is, transfinite number labeling what hyperrooliadicity it has, so to speak. But that may just be because of my description frame. But the question is, in the hierarchy that goes from pure computation universality at the level of the rooliad down to the sub-rooliad of things which are decidable within computation universality, two things which are in the hyperrooliad that are decidable only in oracles on computation universality. And the question is, I think, how do we, this claim that it's a contingent fact that we think of ourselves and exist at the level of the rooliad and not at the sub-rooliad or hyperrooliad levels. Probably should be called hyporooliad and hyperrooliad.
What is the hyporooliad? What even is
something
that?
like a finite state machine, or for that matter, propositional logic.
So it's just something in the rooliad. I mean, it's in it, right?
Yes. And, well, okay, so a question which I admit I don't really understand the answer to is the claim of some, is there within the rooliad the analog of an event horizon where effects from the sort of innards of computing something in logic can't get out? Because, see, here's the thing I'm trying to imagine. Imagine this is the flatlander, except it's not a flatlander, it's a finite state. Imagine that we were purely finite state machines. We live our lives as finite state machines. And we can't see anything beyond that.
Oh, okay.
Then what we would see happening is, it's pretty hard to imagine oneself as a finite state machine. I mean, it's so we would see, what will we see happening? We would see, well, for example, if we have, as a finite state machine, we know that you can't recognize a bracket language, a matched bracket language, if you're a finite state machine. It requires context-free language.
Okay. Yeah.
So, that's a cool thing. If we were finite state machines and we were shown a bunch of bracket things, they would appear random to us. So in other words, okay, so this is kind of the oops.
So what, we're considering the Chomsky hierarchy in the rooliad now?
Yes. So what we're saying is to a sub-rooliad slash hyperrooliad dweller, what do things look like?
Oh gosh.
E.g.,
Yeah. What's it like to be a hypercomputer?
e.g., what's it like to be a finite state machine? And one of the things that if you see a bunch of parenthesis words all matching, we're all with bracket matching, all with delimiter matching, that will look random to you. You won't be able to tell. You won't know why is there, but is not. So in other words, it's like saying there can be true randomness in our universe if there is if there's a hypercomputation going on, there can be true algorithmic randomness. Like you can have, Greg's, Chaitin's, omega number and all kinds of things like that. So
yes,
I don't quite understand the statement. So, this is in our universe. We need to more work should be done on this question of exactly how the causal edges. Oh boy, this is a bit hard to think through. Causal edges in the hyperrooliad, the rooliad, the subrooliad. I think the point is that the causal edges in the subrooliad can never mix with the ones in the ordinary rooliad. I think that's the analogous thing, to the existence of the event horizon. But that needs to be understood better. So good questions. What does it mean monadic, non-monadic? Who's monad? Are we talking Leibniz?
Leibniz?
Are we talking Leibniz or Haskell or what?
Oh yes, right.
I'm not sure. That's like some clarification. Okay. Okay, Peter is asking, what happens when a transformation takes place? What's the action of turning one event into another? This is a long, complicated story about accumulative mathematics versus non-accumulative and so on. We're going to run out of time here very, very soon, unfortunately. But I want to just talk a little bit more about high-level math and equivalences between levels of math. The big contention is that to a mathematical observer, that it is conceivable to find these high-level correspondences between areas of math, that a high-level mathematical observer can find these in the same way. I mean, the claim is in the same way that motion is possible in physical space. It could be the case. Okay, so motion in physical space. To get from here to there, you might need a Star Trek transporter, so to speak. You might need to be
Or a two machine.
atomized.
You just need a two machine.
What do you mean a two machine? What?
This is from my summer school project, right? Translating from one path to another.
Oh, I
These
see.
Single paths. Higher order machines that you can think of mathematically, though it's not necessarily clear if they can be actually physically built.
Okay, you might need to be atomized and reconstituted. So it's a big fact about physics that isn't the case. That we can all walk around and not, and that the version of you that is in a different place in space is still the same you.
Yep.
Now, the fact that it's the same you is in part a conceit on your part.
Yes, right.
Right? Because it is actually different atoms of space.
Yes, right. We're motifs, so to speak. Yes. Right.
And the fact that we imagine it's the same you is up to us. So the analogy in mathematics would be the point in mathematics is that to a mathematical observer, it will look like these areas of math are the same, that there is an equivalence. As opposed to you have to grind it down to the level, and at the level there certainly is equivalence. At the level there's equivalence because of computation universality.
That's just like saying everything's made out of atoms. Right?
Yes, that's right.
Yeah, right. Which is not terribly helpful.
It's not helpful at a human level. Right.
Right.
Yeah. Right. So here's the thing. If we say number theory is the same as geometry, let's say, number theory has a correspondence to geometry. Both of those are made of computation. So the statement that number theory and geometry, at the level where everything is atomized and reconstituted, that is a trivial statement. The question is it possible to get from one to the other in a high-level way?
Mm-hmm.
And the contention is that what we're saying is that yes, it is. And then the question would be, okay, so if it is possible, can we make a little bit more close of an analogy to physical space? And for example, what is gravity in the case of mathematics? Is it the existence of an area where there is high proof density to which geodesics get attracted? And potentially,
Yes.
So in other words, you're trying to get from one area of math to another, and you've got to hop around the black holes.
Yep. Yes.
Because you're trying to get from one area of math to another, and it could be the case that you just get stuck in.
Yeah. Or there's some obstruction, but it might not. It depends on what you mean by density. It's not just density; it's also the topological structure. Because we've seen graphs before, right, where there are these obstructions, even though the graph itself is very dense, so to speak.
Yeah, but an obstruction is something like an event horizon.
Yeah. Yeah. Right. But what I'm saying is it's not just enough. You could have something that's very dense that also has an obstruction in it.
Okay, the other analogy that I think is useful is these higher level constructs are like particles.
Oh yeah, I remember this. We haven't talked about this for a while, I think.
Right, that's the thing that allows
you mean because they persist?
They persist, yeah.
Yeah.
They're things that exist at the Ur level.
Yes.
And but nevertheless are not ground up and, are purely atomized, so to speak. I wish we had a term. If we had a term, if we use the Eames term, they could be emified. Although I think that's going to be, this is the question, the analog of atomized. Purified. It's awfully similar to purified.
Or horrified. Yeah. That's not good. Well, hold on. What's the concept exactly? Are you saying that the particles, they're at the machine level? This is the first point. Is that right?
Well, yes, they're made up of things, just like any topological soliton, any kind of a vortex, all these kinds of things can be thought of as made up of molecules, but they're a higher level kind of thing that.
So if you have, let's say you manage to find, say, you take some multi-combinator, you find what we've called accretions, right? Where you have many combinators at the same fixed point. And that fixed point looks like the axiom of equality or associativity or something like that. Is that what you have in mind in terms of a particle? Is that the kind of
say
thing?
that again? What the?
So, okay. Yeah, no problem. So let's say we're looking at multi-combinators at the machine level. So I've described before that if you have, say, a common fixed point, right? You can see with these multi-combinators that they come together to some shared common fixed point. We've called them accretions before. And let's say that fixed point, looks like it could be axiom of equality, or it could be associativity or something like that. And it could actually end up having its own nice entailment cone. Would this be kind of a particle, something that's made it all the way from the machine level to, say, the fabric, so to speak?
Possibly, yes.
Yeah, okay.
All right, we should probably wrap up here, unfortunately, because I have something else I have to do. But yeah, so we've got some technical things with automated theorem proving to figure out, and I think we're slowly understanding. I think this point about truth and falsity are not the same kind of thing is really kind of an important point.
Yeah.
And
unexpected.
It's very unexpected.
That's pretty usual.
But I'd like to go look at some of the philosophical literature, philosophy of math literature, to see what people have discussed about this, because I have a feeling this may be not unrelated to some of the objections to constructivism that people have.
Interesting. Okay.
Okay. Anyway, to be continued, hopefully soon. This was good. All right, I should go, and thanks to folks on the live stream, and we're sorry we can't answer all the Hyperruliad questions yet. Although maybe we should do a live stream sometime. We need some sort of higher order mathematical logic people here to talk about the Hyperruliad, because otherwise I'm going to get totally confused with the arithmetic hierarchy and its relationship to.
Yes.
The question is the study of the Hyperruliad, there are times in the past in the study of theology and so on where it's like ends up with how many angels are there on the head of a pin, or how does an impenetrable barrier get an irresistible force versus an immovable object, what wins, and so on. And I have a feeling that a bunch of these questions to us will look like those questions. But I think the useful way to think about that is, imagine you were a finite state machine. What would the world that we do understand something about look like to you? And then what does the world that we don't understand things about look like to us? Yeah, lots of interesting questions there. All right, I should go. Thanks, everybody. Bye for now, and happy holidays and all that. If we're not, I think I'm doing one more live stream tomorrow, 2 more tomorrow. My gosh. Okay. and people are still around, we might continue this a little bit more. I'm kind of hot to trot on these topics.
Yes.
All right.